Hi, welcome. Today we're going to take a look at complex numbers. So these are fun. I like them. Mostly they're really pretty straightforward, but they're definitely a little weird. So just kind of hang in there and we'll see what we have. So for starters, by definition, we're going to call the square root of -1 I. So we know that before we haven't really been allowed to take square root of negative numbers because you can't find two real numbers that will multiply together to be a negative. In this case, you can't find two real numbers that would multiply to be, or that would multiply. You can't find a real number that multiplied by itself, there we go, would give you -1. So since that doesn't work, and since we want a definition for this, we're going to call it I. So I is a number. It's called the imaginary number, and it's definitely a little weird. The other thing we get out of this is that I squared then will always equal -1. And that's going to be really important a little bit later, especially when we start multiplying these together. Anytime you have I squared, you're going to get -1. All right, so I have a simplification here of a square root of a negative. I have the square root of -64. Basically, we do this the exact same way we would do any other square root. Square root of 64 is 8, but because there's a negative on the inside, I just call it 8i. All right, that gets us to complex numbers, and that's where we're going to spend most of our time here in this section. A complex number is of the form a plus bi, where a and b are real numbers. A is called the real part, and b is called the imaginary part. So for example, I have 3 minus 5i here. The real part is 3. The imaginary part is -5. Notice with the imaginary part, I don't bother to include the I. It's just -5. All right, so we're going to look next at how we add, subtract, multiply, and divide complex numbers. Okay, some of it's easier than others, but we're going to make it all work, and then we'll take a quick look at roots with complex numbers. Okay, so let's take a look at adding and subtracting. These are actually pretty nice. One way we can do this is to just kind of pretend that I is a variable. It's not. It is a number. But we can kind of pretend it's a variable because for a lot of things that we do, it's going to act really, really similar to just an x. Just weirdly, where if you square it, you get -1. All right, so to add, here I have two complex numbers. I have 7 plus 2i plus 8 minus 3i. Notice the addition sign in the middle. For some reason, people like to overlook the addition sign in the middle and then they start multiplying. I think it's because we have these complex numbers in parentheses, and so sometimes people get a little bit confused. Please don't. It is addition. This is going to be as wonderfully nice as you could ever hope it would be. So let's not overcomplicate it and make it wrong. That would be bad. So I just add the pieces that are the same, just like you would if I was a variable. 7 and 8 are like terms, so 7 plus 8 gives me 15. 2i and minus 3i are like terms, so I add those. 2 and -3 gives me -1, so I get -i. And there we go, there's my answer, 15 minus I. Pretty straightforward. For subtraction, it's the same kind of idea. The big thing you have to watch out for here is that now, because it's subtraction, you have to distribute that minus sign. So if you want, and I kind of recommend, change that subtraction to addition, and then change the signs in the second set of parentheses. I find that to be easier to keep track of the signs and to do the job that we need to do. So 4 and -5 makes -1. -2i plus 6i makes 4i. That's adding and subtracting. That's really all there is to it, and I like your chances. It's pretty straightforward. All right, we're going to complicate things a little bit more on the next board. We're going to multiply, and we'll get ready to divide anyway. All right, continuing on. Now we're going to multiply. The one thing we really want to keep in mind here is that I squared is always going to turn into -1. So otherwise, this is just like any kind of foiling problem that you've ever done. We're just going to multiply everything in the first set of parentheses by everything in the second. So 2 times 3 gave me 6. 2 times -4i is a -8i. 5i times 3 is a +15i. 5i times -4 is a -20i squared. And here's where that I squared being -1 is going to come into play. So you'll see, going from line 2 here to line 3, I combined like terms, -8 and 15 made 7, but I also got rid of the I squared. Right? I squared is -1. But since it's -1, all that happens is that we just keep the number, the 20, but change its sign. So instead of it being a minus 20, we have a positive 20. And then I combine my like terms there. I have 6 and 20, that make 26. And we always put that real part first. So I get 26 plus 7i. And there, I'm done multiplying. So I have one more multiplication problem over here, but I've put a heading above it called complex conjugates. Complex conjugates are complex numbers that are exactly the same, except one has a plus sign in the middle and the other has a minus sign in the middle. Now, what's important here is this. Watch what happens when I multiply these two things together. 3 times 3 is 9. 3 times minus 4i is a minus 12i. 4i times 3 is a plus 12i. And 4i times minus 4i is a minus 16i squared. Well, hopefully what we notice is that these two middle terms are opposites, and so they just get rid of each other. And then over here, I squared is negative 1, so again, my negative 16 turns into a positive 16. So what's nice is notice that when we multiply complex conjugates together, we just got a number. We got 25 out of this. And it turns out anytime you multiply complex conjugates together, you always get just a nice, normal, real number. And that's super awesome. It's going to be very useful here on the next board when we start dividing. So let's get there. Okay, so now we have division. I have directions here. We want to multiply the top and the bottom of the fraction by the complex conjugate of the denominator. So whatever your denominator is, you're going to multiply top and bottom by the conjugate of the denominator. So here's my example, 3 plus 2i over 4 minus I. Now, as you hopefully read, I multiplied the top and the bottom by 4 plus 5i, right? That's the conjugate for 4 minus 5i, 4 plus 5i. And so you can follow through what I did here, but basically I FOILed the top and I FOILed the bottom, right? Just multiplying like we did on the last board. So 3 times 4 gave me 12, 3 times 5i is 15i, 2i times 4 is 8i, and 2i times 5i is a plus 10i squared. On the bottom, 4 times 4 is 16, 4 times 5i is 20i, negative 5i times 4 is negative 20i, and negative 5i times 5i is minus 25i squared. So I know that the I squareds are going to turn into negative 1, just like they did on the last board when we were just multiplying. And I combine like terms. 15 and 8 make 23, so I have 12 plus 23i, and now I just have minus 10. Again, switching that sign. On the bottom, the i's in the middle knock each other out, and I squared is negative 1, which leaves me with a plus 25. So when I clean it up, I have 2 plus 23i all over 41. Now, that's not quite in the standard form the way we like to write these, so I just split my fraction into 2 over 41 plus 23 over 41i. And now we have a complex number in its standard form. It's ugly, and you're going to get a lot of ugly looking things when you do division, just because it's really actually kind of tricky to write a problem where it comes out nice. But there you go, that's how we divide. So we have one more thing to look at in this section, and it won't take us very long. One more board, here we go. All right, so the last thing we want to look at here in this section is finding zeros, where we have some complex zeros. So I have f of x is equal to 5x squared plus 3x plus 1. Since I'm asking you to find the zeros, we're just going to set it equal to 0. Now, this is a quadratic, so I chose to use the quadratic formula, which turns out to be a wonderful idea here because our solutions are going to be a little bit ugly. So I plug it in, and I'm going to be really careful doing the quadratic formula. Please be careful with your negative signs, with your addition, and the order of operations. I get a lot of just kind of silly mistakes that happen here, so just please be careful. Anyway, I square the 3, that gives me 9. 4 times 5 is 20, and 2 times 5 is 10. So then when I subtract, 9 minus 20 gives me a negative 11, and I'm basically done now. I can't do anything else really to clean this up, but I do want to pull that I out, and I would also like to write my answers as actual complex numbers. So again, I'm splitting the fraction, negative 3/10, and then I'm going to split the plus or minus. So negative 3/10 plus, and then I pull out the I, square root of 11 over 10 with I, right, because of the I that comes out of that square root. And then negative 3/10 with the minus sign this time, square root of 11 over 10. And again, that I is coming out because we don't want to leave the negative inside the radical. we want to have an I. So that's complex numbers, and we're going to bring those back in the next section as solutions for our polynomials. And yeah, that's what we'll be doing. So see you then.